Hi everyone, my name is Kevin Jing from Group 10. Now, in this presentation, I will explore how the first-fit algorithm works in memory management using an example with several processes and memory holes. The first-fit algorithm locates memory by searching from the beginning and placing the process in the first available block large enough to accommodate it. The memory is defined as a series of blocks, either marked U, user or hash hole. U represent the user's memory, hash represent the free space in memory. So as you can see, memory segmentation, we have the address values like 0, 10, 45, and 100. Mark the start and end of each segment. Only holes can be combined when needed. So we must always remember, only holes can be combined when needed, meaning two free space next to each other can match, but user memory blocks remain fixed until the process is terminated or moved. So we need to identify the available holes like H1, H2, H3, and H4, and note their size for future allocation steps. So this is updated memory management scheme release. So the following process requests will be received in order from process number 1 until 6, and they have each size in the kilobytes. So now I will show you how to use the first step to allocate the memory. So before move to solution, we need to allocate the memory to the following process. So we just write the process 1 as P1, P2, P3, P4, P5, and the last one P6. Besides, we list out their size in kilobytes. So how does first fit work? The first fit algorithm doesn't scan the entire memory. It simply places the process in the first hole that is large enough to accommodate it. This makes first fit faster than the alternative like best fit or worst fit, as it requires the less searching. So when we do the first fit, we need to notice when a process arrives, compare its size to the first hole. Just right put in and it can fit, so we doesn't have to scan the whole hole. If the hole is large enough, allocate the process there. If not, move to the next hole and repeat the process until a suitable hole is found. So this is a key. The first hole that fit is always chosen, even if a better fit is found later in the memory. So now we need to build a table to find the H1, H2, H3, and H4. So we need to find the size of the hole. Usually, we use the end of each hole minus the start of each hole. So the question given, H1 given the end of the hole is 45. So we minus the start of the H1 is 10. So it belongs to 35. So we write down the size in H1, and the following is H2. After we minus the end and start, we got 22. H3, we got 120, and the H4, we got 86 kilobytes. So now we will start to process the allocation. So as I mentioned before, we just directly put in, and if can fit, we didn't have to scan the whole hole. So let's start. The P1, which is 90 kilobyte, is allocated to the H1, which initially has 35 kilobyte, so it's large enough for the P1. So we minus 19, leaving 16 kilobyte after allocation. Now we got a P2, which have the 60 size in kilobytes. So the H1 and H2 is not enough to allocate it. So we move to the H3. Now H3 is available. So P2 allocate to the H3 with 120 kilobytes minus 60 kilobytes, leaving 60 kilobytes. Now P3 got 77 kilobytes. Cannot allocate to H1, H2, even the H3 cannot. So we allocate to H4 with 86 kilobytes minus 77 kilobytes. We got the leaving 9 kilobytes. Now we move to a P4. 6 is allocated to the remaining space in the H1, which now has 16 kilobytes minus 6 kilobytes, leaving 10 kilobytes. And the next is P5, got 33 size in kilobytes. Since the H1, H2 cannot allocate, so the P5 allocate to the remaining space in H3, which had 60 kilobytes minus 33 kilobytes, leaving 27 kilobytes. Now the last one, P6, got only 2 kilobytes. So the first one, O1, allocate to the remaining space in H1, which now has 10 kilobytes minus 2 kilobytes leaving 8 kilobytes. Each processor is placed in the first hole that can fit it, and the size of each hole is updated after allocation. The memory layout now has several processes allocated with remaining holes. So P1, P4, and P6 occupy space in O1. H2, 22 kilobytes remain unused. No process will allocate here. And the H3, initially 1120 kilobytes. After allocating P2 and P5, 27 kilobytes remain. O4, initially 6 kilobytes. After allocating P3, which has the 77 kilobytes, 9 kilobytes remains. So the first switch algorithm prioritizes fast allocation but can lead to the fragmentation where memory has small holes that cannot be used effectively. Now, after we updated the memory allocation table, so don't forget to draw back the pre-list. The memory layout now has several processes allocated with remaining holes. So P1, P4, P6 occupy space in hole 1, P2 and P5 occupy space in hole 3, and P3 occupies hole 4. So we need to draw back of the first bit. There are still unused holes, small holes like the 2 kilobytes left in 8 kilobytes left in H1, 22 kilobytes in H2, and 9 kilobytes in H4. These smaller scatter holes may be too small to fit the news process, leading to the external fragmentation. So although processes are allocated quickly, memory fragmentation can reduce the efficiency of memory usage. Now we need to update the memory address. P1 is placed from 10. So P1 is placed from 10 to 29. The remaining hole is from 29 to 45. And the second one, P4, is placed from 29 to 35. The remaining hole is from 35 to 45. P6 is placed from 35 to 37. The remaining hole is from 37 to 45. And the remaining we just write down as the list. Now P2 is placed from 115 to 175. The remaining hole is from 175 to 2375. P5 is placed from 175 to 208. The remaining hole is from 208 to 235. And the last one, P3 is placed from 294 to 371. The remaining hole is from 371 to 380. So in this step, we update the starting address of the hole by adding the size of the process that is allocated. This helps visualize how the memory is being filled up and how much free space hole remains after each allocation. So in conclusion, the first fit algorithm allocates process to the first available hole that fits. It is efficient in terms of simplicity but can lead to fragmentation. In this example, after allocating all the process, we are left with small unused memory chunks in the host. That's all for me. Thank you.
Hello everyone, I'm Yomeyan from Group 10. So the topic chosen by our group is Dynamic Partitioning Placement Algorithm. So we have done our one question by ourselves. Let's move on together. So here you can see that it's a heap memory management scheme with the following three lists. So the U stand for use and the H stand for hold. So actually we can combine two hash into one hold. So here we would have four hold, which is H1, H2, H3 and also H4. So we have to always remember that only hold can be combined. The use cannot be combined. So the updated memory management scheme free list will be as follows. And this is the following process request will be received in order. So we have to show how the memory request above allocated using each of the dynamic partitioning placement algorithm. For me, I will explain for the best fit solution. So before we move to the solution, I will translate the table to become like this. For process number 1, I will write P1. For process number 2, I will write P2. And for process number 3, I will write P3. Process number 4, I will write P4. And process number 5, I will write as P5. And process number 6, I will write as P6. So based on this question, we will do for the best fit solution. So how does best fit solution work? there is two rules for best fit solution. The first one is scan all the hole and put in a smaller value hole if P and dirt. And the second one is if there have two holes empty or having the same value, we have to choose the first hole, start from left. So now I will demo how it works. So the first step for best fit solution is we have to build a table. So the table will contain hole, size, and also the process. So we will put the H1, H2, and H3 into the table in a sequence. So it will become like this. So after we put all the hole into the table, now we will go to the size. So size is actually a hole size. For example, for H1 size, we will use the 45 minus 10 and then we get 35. So 35 will then put into the table. And for H2, we will take 77 minus 55 and we get 22. Then 22 will then put into the table. And it's also for H3, we will use 235 minus 115 and then we will get 120. Then 120 we will put into the table. And last is for H4, we will take 318, then minus 294, then we will get 86. So 86 will then put into the table. So now the second step for best fit solution is put in the process into the table. In this step, we will also refer back to the two rules we have declared before this, which is scan all the hole and put into a smaller value hole if the process enter, and also if there have two hole empty or having the same value, we have to choose the first hole, start from left. So now we will do for P1. We will scan all the hole from H1 to H4. So for H1, we use 35 minus 19, then we get 16. So for H2, it will be same like H1, then we will get 3. For H3, we will get 101. And for H4, we will get 67. So followed by the rules, we have to choose smaller value hole. So in this case, we will choose 3. So we have to put P1 into H2 and we have to update H2 size. So here is the updated table. Now we will do for P2. So we have to always remember that if it cannot fit, we have to skip to check the next hole. So for P2, it is 60 and for H1 size, it's only 35. So it means that it cannot fit, so we just skip to check the next hole. For H2, it also cannot fit, then we skip. So for H3, it can fit, so we use 120 minus 60 and then we will get 60. And for H4, we will get 26. So remember that we have to choose the smaller value hole to put in the process. So in this case, we will choose H4 to put in the process. So we will next update the H4 size. Then now we do for P3. So it's also the same rules. For H1 cannot fit, then we skip. H2 also cannot fit, then we skip. For H3 can fit, then we use 120 minus 77, then we will get 43. And for H4, we cannot fit, then we skip. So in this case, we only can put the process into H3. So we have also to update the H3 size. Then for P4, we will also check for H1 to H4. For H1, we will get 29. H2 cannot fit, we skip. H3, we will get 37. H4, we will get 20. So we must always choose the smaller value hole to put in the process. So we put P4 into H4, then we update the H4 size. So for P5, H1 we will get 2, H2 cannot fit, then we skip. H3 we will get 10 and H4 cannot fit, then we skip. So we will choose H1 to put in the process, then we will update the H1 size. So for P6, H1 we will get 0, H2 we will get 1, H3 we will get 41, H4 we will get 18. So always remember that we have to choose the smaller value hole to put in the process. So in this case we choose H1 to put in P6. Then we update the H1 size. So this is the completed table. Now we will go to the last step for best fit solution, which is we have to put process into the according hole. So we will use the table here to help us put in the process. So for H1, we have P5 and P6, so we put into the memory memory list. Then for hash 2 we have P1, so we put P1. Hash 3 only have P3, and hash 4 we have P2 and also P4. Then we have to draw back the memory list. For you just directly take from the question and sub it into the table. But for the hash, you have to see what process have entered it. So for hash 1, there is P5 and P6, so we list back P5 and P6. And for the size, we have to use the previous size plus with the process size in kilobytes. So for P5 size, we use 10 plus 33, then we get 43. Then we put it into the table. And it also for the P6, we use 43 plus 2, then we get 45. Then we put 45 into the table. Then you can see here the hash 1 execute until 45 and P6 also execute until 45. So it means that there is no empty hole, so we can just proceed. So we proceed with U until 55. Then for hash 2 there is only P1, so we list P1. And for P1 size we have to use 55 plus 19, then we get 74. So you can see here the hash 2 execute is until 77, but hash P1 only execute until 74, so it means that there is an empty hole, so we have to put here hash. Then we just proceed with the U and we will get like this. And for hash 3 there's only P3, so we list back P3. And it's also for the size, we use 115 plus 77, then we will get 192, then we put it into the table. Then you can see here also the hash 3 execute is until 235, but the P3 only execute until 192, so it means that there is empty hole, so we have to put hash. Then after that we proceed with the U, and for hash 4 there's P2 and P4, so we list back P2 and P4. So for the size is also the same concept. So for P2 size we use 294 plus 60, which is the P2 size in kilobytes. We will get 354, then we put 354 into the table. And now we do for the P4 size. So for the P4 size we use 354 plus 6, so we will get 360, so we put it into the table. Since hash 4 execute until 380 and P4 only execute until 360, so it means that there is an empty hole, so we put hash there. After that we just proceed with U, then we will get the table like this. So this is our final answer for best fit solution. Thank you very much.